Dear students, in this video we are going to discuss the questions from JEE Main 2023 entrance examinations, and these questions are from the topic concentration terms. The first question is the quantity with changes with the temperature is, first option is molarity, second option is mole percentage, third option is molality, and the last option is mole fraction. Here the answer is molarity. Listen, we have studied a number of concentration terms for solutions, of which the temperature dependent concentration terms are, first one is molarity, second one is normality, third one is percentage by volume, and the fourth one is percentage mass by volume. These concentration terms are temperature dependent because these are based on the volume of solvent or solution. As temperature increases, volume increases, therefore concentration changes. The temperature independent concentration terms of solutions are, first one is molality, second one is mole fraction, third one is percentage by mass, and the fourth one is parts per million. In these concentration terms, the amount of solute and solvent are expressed in terms of mass or number of moles, which will not change with temperature. Now the second question is, a solution of sulfuric acid is 31.4% H2SO4 by mass and has a density of 1.25 gram per ml. The molarity of H2SO4 solution is dash molar, in bracket nearest integer, and the molecular mass of sulfuric acid is also given, that is equal to 98 gram per mole. Listen, in this question, density of the solution and its percentage by mass are given. We need to find out its molarity. We know the relationship between the density of solution, percentage by mass, and the molarity of the solution is molarity into molecular mass of solute Mb is equal to 10 into D into X. Then substituting the values, molarity capital M into molecular mass is 98, that is equal to 10 into density of solution is 1.25 into percentage by mass is 31.4. Therefore, molarity M is equal to 10 into 1.25 into 31.4, the whole divided by 98, that is equal to 4 molar. So here the answer is 4. Then question number 3. If a substance A dissolves in a solution of a mixture of B and C with their respective number of moles as Na, Nb and Nc, then the mole fraction of C in the solution is, option number 1, Nc divided by Na into Nb into Nc. Option number 2, Nc divided by Na plus Nb plus Nc. Option number 3, Nc divided by Na minus Nb minus Nc. Option number 4, Nb divided by Na plus Nb. This question says about a solution containing 3 components, capital A, capital B and capital C. Number of moles of A is Na, that of B is Nb, and that of C is Nc. We need to find out the mole fraction of C. We know the mole fraction of a component in a solution is equal to the number of moles of that component in solution divided by total number of moles. Here mole fraction of C is equal to number of moles of C divided by total number of moles. That is Nc divided by Na plus Nb plus Nc. So here the answer is option number 2. Then question number 4. The density of 3 molar solution of NaCl is 1 gram per ml. Molality of the solution is dash, in bracket nearest integer. The molecular mass of NaCl is given 58.5 gram per mole. In this question, density and molarity of an NaCl solution are given. We need to find out its molality. Molarity of NaCl solution, capital M, is given, that is equal to 3 molar. Density of solution small d is equal to 1.25 gram per ml. Then we know the relationship between density of solution, molarity and molality as density small d is equal to capital M, molarity, into 1 by molality, that is small m, plus molecular mass of solute Mb divided by 1000. Substituting these values, density of solution is 1.25 and the molarity capital M is 3 into 1 by molality plus molecular mass of solute is 58.5 divided by 1000. From this, the molality of the solution can be calculated, which is 2.79 molar. So the answer is 2.79. The next question number 5. The molality of a 10% in bracket V by V solution of dibromine in carbon tetrachloride is X. X is equal to dash into 10 raised to minus 2 in bracket nearest integer. Given that molecular mass of bromine is equal to 160 gram per mole, density bromine is equal to 3.2 gram per cc and density CCl4 is equal to 1.6 gram per cc. Listen here, 10% V by V solution means 10 ml bromine plus 90 ml CCl4 gives 100 ml solution. Now we can find out mass of bromine, that is equal to volume of bromine into its density. Volume of bromine is given as 10 ml and density is equal to 3.2, that is equal to 32 gram, that is represented as WB. Then we can find mass of CCl4. It is also equal to volume into density. Volume of CCl4 is 90 and its density is 1.6, that is equal to volume into density is equal to 144, which is represented as WA. Then molality of the solution can be calculated as small m is equal to WB, that is weight of solute, into 1000 divided by MB, that is molecular mass of solute, into WA, that is weight of solvent in gram. Substituting the values of WB, MB and WA, we will get the molality of the solution as 1.39, that is equal to 139 into 10 raised to minus 2 molal. So here the answer is 139. Then question number 6. 5 gram of NaOH was dissolved in deionized water to prepare a 450 ml stock solution. What volume in ml of this solution would be required to prepare a 500 ml of 0.1 molar solution? Here the weight of solute WB is equal to 5 gram and the molecular mass of solute MB is equal to 40 gram because the solute is NaOH and the volume of the solution capital V is equal to 450 ml. Then molarity of the solution is WB into 1000 by MB into capital V in ml. Then substituting the values of WB, MB and the volume of the solution V, we will get molarity of the solution as 5 by 18. Now a certain volume of this solution is diluted to 500 ml solution having molarity 0.1. For the dilution of the same solution, we can use the equation V1M1 is equal to V2M2. V1 and M1 are molarity and volume before dilution and V2, M2 are volume and molarity after dilution. Then substituting the values of M1, V2 and M2, we can calculate volume, initial volume taken for dilution V1, that is equal to 180 ml. So here the answer is 180. Then question number 7. The number of units which are used to express the concentration of solution from the following is: first one is mass percent, second one is mole, third one is mole fraction, fourth one molarity, fifth one ppm, parts per million, and the sixth one molality. It is a simple question. Here the answer is 5. 5 units are concentration terms, that is mass percent, mole fraction, molarity, ppm and molality. Mole is not a concentration term. Next question number 8. The density of a monobasic strong acid in bracket molecular mass is equal to 24.2 gram per mole is 1.21 kilogram per liter. The volume of this solution required for the complete neutralization of 25 ml of 0.24 molar NaOH is dash into 10 raised to minus 2 ml in bracket nearest integer. Here density of the solution is given as 1.21 kilogram per liter. That means weight of 1 liter solution is equal to 1.21 kilogram. We know 1 liter solution contains almost 1 liter water. Weight of 1 liter water is equal to 1 kilogram or 1000 gram because density of water is equal to 1 gram per cc. Now we can calculate the weight of solute present in the solution. Weight of solute WB is equal to weight of solution, that is 1210 gram minus weight of solvent, that is 1000 gram, that is equal to 210 gram. Then we can calculate the normality of the solution, that is N is equal to WB into 1000 divided by EB, which is the equivalent mass of solute into volume in milliliter. Equivalent mass of solute is equal to molecular mass divided by basicity. Here the basicity of acid is given as 1, therefore its equivalent mass is equal to molecular mass. Substituting the values of WB, MB and volume of the solution, we will get normality of the solution as 50 normal. Now a certain volume of this solution is required for the complete neutralization of 25 ml of 0.24 molar NaOH solution. We know for the neutralization between an acid and base, the equation is V1N1 is equal to V2N2. V1 and N1 are the volume and normality of acid solution. V2 and N2 are volume and normality of NaOH solution. Here V1 is the volume of acid used for neutralization that we need to find out. N1 is its normality, that is 50. V2 is the volume of NaOH used for neutralization, that is 25 ml. And N2 is the normality of NaOH, that is equal to 0.24. And because for NaOH, its normality is equal to molarity because its acidicity is equal to 1. Acidicity means the number of replaceable OH minus ions. Then we can find out the volume of acid used for neutralization. V1 is equal to 0.12 milliliter. That is equal to 12 into 10 raised to minus 2 milliliter. So here the answer is 12. Then question number 9, it is a multiple choice question. The question is, the molarity of an aqueous solution containing 5.85 gram of NaCl in 500 ml water is given that atomic mass of sodium is equal to 23 and that of chlorine is equal to 35.5 gram per mole. Here the option number 1 is 20, option number 2, 0.2, option number 3, 2, and option number 4 is 4. Listen, it is a very simple question. Here weight of solute WB is given as 5.85 gram. Volume of the solution B is equal to 500 ml. Then we can calculate the molarity as weight of solute WB into 1000 divided by molecular mass of solute MB into volume in milliliter. Then substituting these values, we will get the molarity as 0.2 molar. So here the answer is option number 2. Now question number 10, which is also a multiple choice question. The question is, what is the mass ratio of ethylene glycol? Its molecular formula is C2H6O2 and the molecular mass is 62 gram per mole. Required for making 500 gram of 0.25 molar aqueous solution and 250 ml of 0.25 molar aqueous solution. Option number 1 is 1:2. Option number 2 is 1:1. Option number 3 is 3:1. And option number 4 is 2:1. In this question, two solutions are prepared by dissolving ethylene glycol and these two solutions have same molality. In the first case, we need to prepare 500 gram solution having molarity is equal to 0.25. And in the second case, we need to prepare 250 ml solution having same molality, that is equal to 0.25. Here we need to assume that 250 ml solution is equal to 250 gram solution and mass of solution is equal to mass of solvent. In the first case, molality of the solution 0.25 is equal to weight of solute W1 into 1000 divided by molecular mass of solute, which is 62, into weight of solvent 500. This equation is taken as 1. In the second case, molality is the same, that is 0.25 is equal to weight of solute W2 into 1000 divided by molecular mass 62 into volume of the solvent is 250. This equation is taken as 2. Then divide equation number 1 by 2. We will get W1 by W2 is equal to 2 by 1. Therefore, W1 is to W2 is equal to 2:1. So here the answer is option number 4.